So in this problem, we're given the ratio of the argon atoms to the potassium atoms. The potassium atoms are radioactive. These ones are stable. And we're told that this is equal to 10.3. We're also told to assume that all the argon atoms are produced from potassium atoms. So that tells us that the initial number of atoms was equal to the number of argon atoms plus the number of potassium atoms. And what we need to do is find out the age of the moon rock. So we're going to be using that the number of atoms is equal to the initial number of atoms times e to the minus lambda t, where lambda is the decay constant. And this is related to the half-life through lambda is equal to log 2 over the half-life. And in this case, we're told that the half-life for the radioactive potassium is equal to 1.25 times 10 to the 9 years. So lambda is equal to log 2 over 1.25 times 10 to the 9, and that's as long as our t in this equation here is measured in years. So now we're going to need to use this equation here. We know what the initial number of atoms is. The final number of atoms, that's the number of radioactive atoms. So that is equal to Nk. So we can write that Nk is equal to NAR plus Nk, because that's just our initial N0, e to the minus lambda t, and lambda is given by this log 2 over 1.25 times 10 to the 9 times t, where t is in years. So we've got, in this case, Nk over N argon plus Nk. Now let's just simplify this down a bit, because we've got this equation up here, and we can rearrange this equation here to write, well, N argon is equal to 10.3 Nk. So we can replace this with this expression here. So doing that, we've got Nk over 10.3 Nk plus Nk. So now Nk is a common factor on the top and on the bottom. So we end up with 1 over 10.3 plus 1, which will be 1 over 11.3. And now we've got we just divided this by this, so we've still got this left. This is equal to e to the minus log 2 over 1.25 times 10 to the 9 times t in years. Okay, so now we want to get rid of this exponent. So to do that, we'll need to take the logs. So we've got log of 1 over 11.3 is equal to minus log 2 over 1.25 times 10 to the 9 t. This you can just enter into the calculator if you don't want to simplify it any further first. And when you do enter that into the calculator, you get minus 2.4248 is equal to minus log 2 over 1.25 times 10 to the 9 t. And so the negative signs here cancel out, and just rearranging this, we end up with t is equal to 4.37 times 10 to the 9 years.